Do you remember in the optimizing the Z-axis video where I show how using 4 rails on the Z-axis made a significant difference? Well, now I'm taking that a step further by combining it with a symmetric gantry on the X-axis. The result? A good rigidity no matter what kind of load you are dealing with. This isn't a hunch. It's back on finite element analysis. With two loads of 49 newtons applied in the X and Y direction at the spindle tip, we are looking at a total deflection of just 9 microns. That's pretty solid, especially considering that this machine is made out of aluminum. Most of the frame is aluminum plates, and just the screws and the linear guide rails are not. And here is where we are having a different design from the typical gantry design. Usually we used to see 2 rails, but we are having 4, and this is just because the symmetry is going to be beneficial, and the other situation is that our gantry is going to stay static. It is not traveling along the y-axis as many routers in the market, but these have some special assembly challenges. Calibration is crucial, especially when it comes to achieve perfect parallelism and positioning. The goal here is to avoid excessive preloading while still keeping the benefit of that added rigidity. So, what do you think? Your feedback is super valuable to me, so let me know in the comments. And if you are curious about the background behind these design choices, be sure to check out my other video on the evolution of my 3018 CNC router. Trust me, it will give you a lot more context on how we got here.